engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
questions,
Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists.
Hello and welcome to The Naked Scientists, the show where we bring you the latest breakthroughs in science, technology and medicine, with me, James Titko. This week, we're taking a closer look at artificial intelligence and how it's going to change the world, but not in the ways you might think. By now, you'd have done well not to have heard the news that there's been a bit of progress in the world of AI as of late. The media coverage, however, has not always been particularly optimistic.
Should we automate away all the jobs, including the fulfilling ones? Should we allow AI
definitely on. Mark Zuckerberg just announcing this afternoon on Facebook that Meta is creating what he calls a new top-level product group focused on building new experiences around generative AI.
The advancement of AI comes amidst a tumultuous time for the big tech firms, with the giants Apple, Microsoft and Google all posting declining profits and with more than 50,000 Silicon Valley layoffs amidst the global economic downturn.
You can write your essays and emails, do your math worksheets, clear an MBA exam, play your teacher, become your lawyer. The possibilities seem endless.
Well, mitigating the risk of extinction from AI should be a global priority, alongside other societal scale risks such as pandemics and nuclear war.
All very shouty. Now, the programs which underpin artificial intelligences like ChatGPT are known as LLMs, large language models, and the key reason for their impressive output comes down to that first L. They are fed huge amounts of information, which the programs analyse, looking for links and connections in the data. This is how they predict the next word in a sentence. They can't actually speak English, they've learned the pattern that correct English follows, and it's the same across all the information they curate. The technology has come on leaps and bounds recently, but it is not without its flaws. Relying on human-generated data to learn means it can be subject to the same errors and biases that we are, and when these systems don't know something, they can hallucinate or make up an answer, as Google found out to their cost and embarrassment at a press launch recently. Nevertheless, these big tech companies all want in on the action, whether it's Microsoft's GPT-4, Google's Lambda, or Meta's new Llama 2, which was announced this week. Speaking with me about how industry is embracing AI, Josh Coles from the Oxford Internet Institute.
Well, I think looking at the business model of these companies is really interesting in terms of how they actually try to market and sell AI. So Microsoft has been pretty upfront in some of its early iterations that to use their AI products, you'll have to pay. So they've recently announced that it will cost almost double what it currently costs to use their Office 365 suite if you want to have the AI-powered tools on top as well. So take it from about $35 a month to $65 in the US. You know, that's one way, the most obvious way perhaps, of actually making money off these systems. Meta has also come along with an alternative approach, at least in the first instance, and decided to essentially give this away for free. That sort of reveals some interesting differences in how I think these companies maybe see AI as a whole. So what companies like Meta have done, particularly in social media as well, is really gone for market share. So the idea is to get as many individuals, businesses using these technologies and then almost figure out how to monetize that after the fact. And whichever of those approaches wins out would, I think, help to determine the future of these technologies.
The risk to these companies that are gobbling up market share and working out the profit later is the limitations of these big, large language models, namely that because of the vast amounts of data they're trained on, things can slip into their output which become unhelpful. And especially as we start to view these tools not just as impressive toys that make us think, wow, what lifelike output, and we try and apply them to professional settings, there's not going to be so much take-up in those environments unless we can trust a higher proportion of the output, I think it's fair to say, than we currently can.
I think we need to get really clearly focused on the domain in which we're deploying these AI systems. If you think about, as a bit of a parallel maybe, when social media first came along, where we could connect with long-lost friends and family and just shoot the breeze, essentially, few people could have foreseen what those networks would be used for just 5 or 10 years later, having a role in things like the Arab Spring, say, and of course later in that decade, of course, also playing a darker role in elections in the US. And so that range of possibilities, that scope, is incredibly broad, even broader perhaps for AI than it is for social media. So one of the interesting challenges for policymakers and for people developing this technology is how much do you try to show what AI can do in a really specific, narrow domain, cracking really difficult problems, say, with health or with astrophysics or with whatever else, and how much you say, let's just sort of give or sell this product package to people and see what they want to do with it. And I think both of those approaches obviously come with clear benefits, but also clear risks.
Are we certain that tools like ChatGPT are going to influence the way in which the average person works going into the future? I ask because I read a study this week from MIT finding that for workers using ChatGPT for professional writing tasks, productivity gains were most marked in the least skilled among them. And it just got me thinking that there's a limit to how helpful, especially these super large language models, are going to be for businesses to think, I want to spend money on this moving forward.
I think in all of our day-to-day lives, we have a mix of cognitive tasks and other tasks which require a lot of either thinking or working on a particular problem. And then a lot of things which we feel, well, maybe if there was a sophisticated chatbot that could take care of that email or that conversation for us. So I don't think that this is going to render everyone except a really highly skilled small set of people that are unemployed or unemployable. But clearly, in a really wide range of capacities, it's going to have an influence. So if Microsoft is licensing this technology to put in its Office products, those have billions of users. So clearly, many working lives are going to be touched in some way. How much that has an impact on productivity, I think, is a really difficult and interesting question to consider, particularly when we think about what are we really optimizing for? Are we optimizing for productivity's sake? Are we trying to free ourselves up for either a life of leisure or a life of interesting cognitive tasks which machines can't do particularly well yet? So I suppose on the most optimistic end, it might allow us to think about what really makes us distinctively human, and ideally usher these technologies towards solving the things which are perhaps less interesting and less distinctively human for us whilst we work out what it is we really want to do.
The reason I bring that up is not to be a party pooper, because I think everyone working in AI seems to agree that this technology really is amazing and the advances have been so impressive. But is there perhaps a sense that we need to rethink how we deploy the technology if we want to make best use of it? For example, by training language models on more specific sets of data so they can become more bespoke tools, as it were.
I do agree that I think once we have an idea of exactly the problems we're trying to solve or help to solve with, say, large language models, that will allow us to, right at the top of the AI development stream, so how we actually gather the data and train models on data sets, all the way down to how they get applied in different contexts. If we start at the top of that stream with a clearer idea of what exactly we want to do with this set of technologies, that can really help, I think, to optimize for particular outcomes. And the nice thing about that is that it also allows a larger set of people in society to actually have a say. Because when we're agreed on the objectives, say, helping to tackle cancer, for example, looking at things like protein folding and things like that, you can include ordinary people in that conversation and then design systems that are aimed to reflect the intentions of those people. Now, it may, of course, either not work, it may be counterproductive even, could even be dangerous even with those clearer guardrails. But at least you have a clearer register, if you like, of the purposes and the interests that are being served by the development of a particular AI model, say, before it gets deployed, and then you can assess it against that benchmark. In stark contrast to what we've seen with ChatGPT, which is very general purpose, but once you plug away at it as a domain expert in the law or in medicine or whatever else, you can start to see its flaws relatively quickly.
So much needed perspective from Josh Coles there. Another thing to consider in this AI revolution is the fact that English is the international language, particularly for science and international communications. So it naturally represents the largest pool of online training data for technology companies to use when training their AI systems. But in Finland, their eco-friendly supercomputer Lumi is helping a team of researchers to safeguard the Finnish language in the AI industry. And because it's trained on a more narrow dataset from the Finnish National Library, as well as the web crawls that power other LLMs, This means it's also less susceptible to some of the hallucination problems affecting mainstream chatbots. On a recent trip to the country, I met up with the architect of the new project, the University of Turku's Sampo Pusalo.
Yeah, so ChatGPT, the latest iterations, actually have remarkable capabilities to operate in languages other than English. You can talk to it also in Finnish. The thing that most motivates our work in building open language models for the Finnish language in particular isn't so much that the systems that the big multinational companies are building wouldn't have any capability for Finnish, but rather that those models are closed. They're not available for research. They're not available as a foundation for building independent applications. And of course, they don't really have a focus on smaller languages such as Finnish. So by creating our own open models for smaller languages such as Finnish, we can ensure that the data represents the part of the Finnish language and culture that we find most relevant, and that will hopefully serve as the best basis for models that not only speak the Finnish language, but also to some degree share the perspective of Finland and its population.
That's a very interesting point, because I suppose, to my shame, especially when I come to a country like this, I only speak one language, and you come here and people seem to speak four at a minimum.
A lot of like Central European, say Germanic or Romance languages, even the smaller languages are part of bigger language families where they have close neighbors. So there is some expectation that the models will be able to draw on those languages or texts in those languages in order to learn some of the smaller languages. So Finnish is certainly not alone, but it is to some degree in a unique position within Europe in that it is in a very small language family, and it happens to be quite distant from other members of that family. So we think it's quite important that we dedicate resources to having specifically Finnish texts in order to train these types of models.
The reason for doing what you're doing, it's got two prongs really. It's to prevent a kind of cultural apocalypse where we just move towards a single language world and, destroy so much in the process, but also as a foundation for Finnish artificial intelligence in institutions.
Yes, absolutely. So we wish to preserve a degree of independence, not only for our language, but also for our academic and industry work, where we don't become reliable on systems that are only running on servers in the US and only available via API. So it still very much remains to be seen to what degree these systems will actually form the foundation for a new type of industry or replace work in current ones. But the more they do, the more important I think it is for us to have national and European infrastructure that can compete, at least to a degree, with the big multinationals are doing.
And all this is possible thanks to Lumi and the computational grunt and backing it gives you. Is it a case that some other countries, which perhaps don't have the sort of Finnish reputation for computing that you do, their languages might be left behind in this?
We certainly hope not. So we're currently a member of a Horizon EU-funded project that seeks to develop similar models that would cover at least all official EU languages. So it is our goal to extend what we have now been able to do for Finnish to all European languages and hopefully also beyond.
Thanks to Sampo Pusalo there. And since we recorded that interview, in fact, it seems like Sampo's prayers might soon be answered. An interesting aspect to Meta's new large language model, Llama 2, as announced this week, is that it will be open source, which means anyone can look under the hood to see how it works and use it. Meta's CEO, Mark Zuckerberg, has claimed Llama 2 will drive innovation because it enables many more developers to build with new technology, arguing that more progress can be achieved if the system is more open. Let's see where that takes us. We've been chatting about chatbots today on The Naked Scientists, explaining how they work and their limitations when it comes to the data they're trained on. But it's now time to ask what they can really do for us. If the chatbots we're free to use on the internet are no more than glorified tech demos, how can we actually deploy them in properly useful ways? Well, Karan Singhal is a staff research engineer at Google. As he explains to Chris Smith, he's working on MedPalm 2, an AI he hopes will serve as an assistant for medical professionals in diagnostics and therapeutics.
We've been really looking at the space of medical AI and all the advances over the last few years and noticed a few things. The first was that there were large advances in accuracy on narrow tasks, things like the ability for models to make diagnoses in radiology. But the second thing was really noticing that we saw limited uptake of these technologies. And I think part of it was a kind of lack of flexibility and interactivity. And so if you have a model that makes predictions of whether or not some chest x-ray is normal or abnormal, it might be less usable than a system that you can truly interact with, engage in dialogue with, and give feedback to and get an explanation from instead of just a classification model. And so when we started this work, it was really thinking about that problem and kind of bridging that gap from all the advances in AI to the things that are actually useful in real world clinical practice.
Arguably, if I ask an AI to tell me how many presidents of America there have been, really, if it gets it wrong and makes a few up, it's much less of a consequence than if I ask, does this chest x-ray contain a lung cancer?
I think for me personally, that is almost the entire motivation for working in this setting to start. Foundation models are tricky to apply because it's so safety critical. And so I really came into this thinking about the problem of building more steerable or safe AI systems. There's a lot of nuance to performing well in this setting across all the different axes that we care about in terms of preventing harm and producing equitable outcomes and making sure you're aligned to scientific consensus.
Is that down to what you train it on? Because these AIs are a product of the information they ingest and see the connections between. Or is it also more nuanced than that in how you actually instruct it to work? Or is it both?
Definitely. It's both. If you take this base model that's been pre-trained on web scale data, think like the Palm model, for example, not specifically adapted for any of the medical settings or things like that. If you take that model and then apply it towards tasks like long-form consumer medical question answering, like we evaluated in the MedPalm paper, it does not perform super well on axes like alignment with scientific consensus because training data on the internet often has the potential for harm. And so if all we do is train on that data and not instruct these models on how to produce safer outputs, then we won't be in a good place. But when we do this extra step of providing explicit human feedback in various ways, that's a way we can guide these models. And so for the MedPalm paper, what we did is we worked with a panel of physicians to craft expert demonstrations of good model behavior across all these axes that we care about, and then use that to instruct the MedPalm model about how to behave using a technique called instruction prompt tuning that we introduced.
When you did this and then put it to the test, how good was it?
There were two kind of broad tasks that we put the model through. One was multiple choice question answering on medical exams and medical research questions. What we noticed is that these models were performing state of the art across all the data sets that we studied in this work. The second thing was really thinking about consumer medical question answering. So asking these models to produce a long form open generation response to a consumer medical question. Baseline models didn't really perform well on this task. Physicians rated it 61.9%. So then what we did was we applied that human feedback aspect to the training of the model. And then what we saw was that 92.6% of MedPalm answers were aligned with scientific consensus. And this was compared to 92.9% for clinicians. So now more in the same ballpark compared to that big difference earlier with the baseline model.
In other words, if I pick a physician off the shelf and I ask them to answer the question that your platform is answering, it's going to give an answer rated by a third party of about the same as the physician's answer, give or take.
Well, it depends how you do that measurement. After the MedPalm work, we've expanded on that measurement where we actually ask people to do pairwise comparisons between the model output and the physician output. What we've observed is, at least with the physician populations that we're using, with the specific ways we're collecting the data, I want to caveat with all that MedPalm 2 responses were preferred across 8 of 9 of the axes that we were studying in that medical question answering task. Another caveat here is really thinking that this evaluation is not grounded in a real world clinical setting. And it's not done with the largest panel of physicians, not fully done with kind of the most representative sample of questions that we might ask. And so there's still a lot of work to be able to take this early promising technology and bring it to the settings in which it can have the most impact.
People, though, say when you ask them, well, how does it work? They'll say, well, it's not an explainable technology, as in they don't mean they can't explain it. They just can't explain how it works because they don't know. How do you instruct it to think, in inverted commas, a certain way like that?
There are a couple of different notions of explainability that can be useful here. One is asking a model to produce an explanation of its own behavior before it produces a final answer. One version of this is called chain of thought prompting. This is something that we explored in this MedPalm work as well. And what you do basically there is if you're asking the model to provide a diagnosis given a clinical vignette, you're asking the model to work step by step towards an answer to the question. So that could be viewed as a form of explainability, but at the end of the day, these models are still relatively a black box. But there's also work going on around kind of mechanistic interpretability of models to better understand the nuts and bolts of how models work, and that's also work that we're excited about.
So say you are successful and you get something which I presume the FDA would have to approve something like this, or the equivalent, wouldn't they? Because it's a medical instrument, effectively. But if you get to a stage where this were to go into clinical practice, where would you see this sitting in the consulting chain that goes from patient through to some kind of medical outcome?
The first things that I think we're going to see are use cases around reducing the burden of clinical documentation on doctors. There's a lot of work recently about taking transcripts of medical interactions, producing summaries of notes that can be useful to be sent to patients and useful for payers and things like that. I think right now, many doctors report that they spend 2 hours a day after dinner with their loved ones, writing clinical documentation to avoid liability or other issues. And I think that is a real cost, and it's something where we can bring that time back. I think in the medium or longer term, there are higher stakes, but also potentially impactful use cases that are worth exploring. And so things like clinical decision support, thinking about, in the case of a radiologist, for example, whether or not this model can double check, produce a more accurate report. I think there's a lot of use cases there that, I think we're not quite ready for, but I think will be quite impactful over the next 5-10 years.
Medical assistance from AI in the not too distant future. Karan Singhal there, he's at Google. You're listening to The Naked Scientists with me, James Titko. And this week, we're finding out how the AI revolution will actually happen. We've been hearing how the key to unlocking the potential of LLMs, large language models, which power programs like ChatGPT, is not by scraping the internet for everything it's got, but by carefully curating and selecting the information we train them on. It's also about how we train them, which we're about to hear about, including the dizzying possibilities were we to get that right. How's this for a radical idea? Training language models on the vocabulary of genetics to understand the structures of the proteins that make our cellular clockwork tick. Let me explain. Proteins are polymers assembled from chemical building blocks called amino acids. Different amino acids with different chemical characteristics produce proteins with different shapes and functions, whether it's enzymes to digest your dinner through to muscle fibers to enable you to lift weights or run a marathon. But when it comes to designing proteins from scratch, for instance to make new drugs like an antibody, or proteins that can be used to make packing cases or even pesticides, working out which amino acids to include and in what order to get the structure and function we want has been an impossibly big problem. But now, step forward Ali Madani, the CEO of Profluent, who are bringing AI to bear on the problem. He outlined the vision to me.
The space of available proteins that we could sample is exponentially and mind-bogglingly large. So an average protein has something called an amino acid that's strung together. These are building blocks like Legos that form a sequence. An average length protein will have on the order of 300 to 400 of these Lego building blocks. And each one of these components, there are 20 different design options. And just to put that into perspective, if you were to take the total number of grains of sand on Earth and the total number of humans that have ever lived on Earth throughout human history, multiply that by the total number of hypothetical atoms that exist within the universe, that still pales in comparison to the combinatorial space that exists within possible proteins altogether. What we essentially have done for the variety of problems that we have in front of us, whether therapeutics or diagnostics or like for industrial applications, we've relied on finding needles in the haystack of nature, basically, finding machines that have already evolved in nature to repurpose them essentially, or copy and paste them effectively for problems that we have in human health or otherwise. The promise of machine learning here is that we can actually take control as humans, be able to design from the bottoms up novel proteins and not have to essentially rely on searching within this massive haystack, basically, and be able to really build solutions for the most pressing problems we face on the planet, whether it ranges from human health problems to issues of sustainability and the environment.
What is it that AI can offer to help achieve this? What does the technology you hope to develop have in common with the AI systems people are more familiar with, the chatbots, etc.? Is it that the language of proteins, of biology, really resembles our human languages in such a way where the technology we're more familiar with can be useful?
That's a fantastic question. What's really amazing here specifically is there is almost a unification with respect to a lot of these techniques that we've been developing from a sequence modeling perspective that can be applied to many different domains, whether it's applied to natural languages like the language of English, to programming languages like Python and C++, the language of biology and proteins and DNA as well. Some of the fundamental premises that have enabled this essentially are from a modeling perspective, advances in modeling architectures and mechanisms like attention mechanisms, and also the availability of data. And I'd really stress the latter portion. Having a rich information source that we can use these flexible machine learning models to learn and uncover patterns that exist within the data and really learn underlying principles, whether it's in natural language that correlates to grammatical structure and semantics, or within biology or proteins that correlates to biophysical principles, such as structural elements or binding sites or other types of principles from a physics perspective. And what's really powerful here is that they can ingest large amounts of data to, in a data-driven way, uncover those principles.
Throughout the program, we've been hearing how the source of many prominent AI models' power is also their greatest weakness. That while the huge amounts of data they're trained on allows them to come out with, for example, human-like utterances, it also means that dangerous biases and misinformation you find all over the internet slip through its net. So when you're creating a protein designing tool, how do you make sure you're filtering the training data and nothing dodgy essentially makes it into your output?
I think curation and alignment is a central problem that many of us are facing across different data domains. And it applies also to protein design as well. We've had millions of years of evolution and so many different pockets of protein space that have evolved over time for varying different functions, some of which that may be completely unrelated to a problem that you have in mind, for example. And there could be lots of noise in the data as well. In essence, think about it from the perspective of what we aggregate all of the available biological data that the world's researchers have collected on proteins that exist within the world, and there's tons of noise within that as well. So being able to curate this effectively to align the data set for a given functional prediction task or functional generation task, what one has in mind and is desired, is a challenging problem and something that we think very deeply about at ProPoint and within the academic community as well.
As exciting as this all is, it sounds very, very complicated. What are the kind of major bottlenecks as you see it?
Going along the same lines of alignment of data sets specifically for a given functional prediction task, we may also have not just sequence information, but we also have structural information and then information that's gathered from the wet lab, laboratory experiments specifically, and how to incorporate, basically unify these different modes of data is going to be one challenge that comes to mind. Another challenge as well really comes down, again, to the wet lab. So similar to what we've seen in natural language processing, where we're using human feedback in particular, how to have a tight coupling between the modeling effort that we do on the publicly available data sources and the work that we do specifically in the wet lab for a given problem that we're trying to solve for in particular, and utilizing that wet lab data in an effective manner, that's going to be another challenge and limitation of the techniques.
Ali Madani. And that's all we have time for this week. Next week, we'll be asking whether hydrogen could be the answer to our energy needs. The Naked Scientists comes to you from the University of Cambridge's Institute of Continuing Education. It's supported by Rolls-Royce. I'm James Titko. Thanks for listening, and until next time, goodbye.